Alright, let's go over the chapter 6 and 7 quiz. Problem number 1, you're integrating from 1 to e, x squared minus 1 over x dx. And the first thing you want to do here is you want to simplify x squared minus 1 over x. That'll simplify to x minus 1 over x. And we haven't integrated yet, so we're still integrating from 1 to e. And all of this is with respect to x. So integrating that, well, that's just x squared over 2 minus the natural log of x. So x squared over 2 when you integrate x, and then the natural log of x when you integrate 1 over x. Okay, and now that we found the antiderivative, we go ahead and apply the fundamental theorem of calculus, the capital F of b minus capital F of a. So we have e squared over 2 minus the natural log of e minus 1 squared over 2 minus the natural log of 1. And I had you guys look over some properties for the natural log. So ln of e should be just 1, and the natural log of 1 should be 0. And this is just e squared minus 1 minus 1 half. Or actually, I mean e squared over 2 minus 1 minus 1 half. And we go ahead and just do some simple arithmetic. So you get e squared minus, or e squared over 2 minus 3 over 2. Remember, 1 is just 2 over 2, so if you take 2 over 2, or you look at this as 2 over 2, that's 2. Negative 2 minus 1, which is negative 3 over 2. The answer here should have been e. And this problem was 1 point. All of the multiple choice was plus 1. Alright, let's look at problem number 2. Problem number 2, you had to do some u substitution. And hopefully you let u equal the denominator. So we have u is equal to x squared plus 1. Dx is equal to 1 over 2x du. So I go ahead and take out the constant 1 half, and I just have the integral of 1 over u du. Remember, I don't want to put my limits of 2 and 3 right now, because what I have is variables u, however my limits are x equals 2, x equals 3, so they kind of they don't make sense, or it wouldn't make sense. So I'm not going to put limits right now until I get this antiderivative back in terms of x. Okay, so integrating 1 over u, it's too easy now. It's the natural log of u. So we have 1 half times the natural log of u, and I'm going to go ahead and, now that I've integrated, I'm going to go ahead and change u back to x squared plus 1. And now I can go ahead and put my limits x equals 2 and x equals 3. Notice that I don't have to put the absolute values anymore, because x squared plus 1 will never produce anything negative, because no matter what x equals, it's being squared, so it automatically turns it positive, and then plus 1, it stays positive. Alright, ready to apply capital F of b minus capital F of a. And so what I did is, once I plugged in my 3 in for x, minus, and then plug in my 2 in for x, notice that I kept the 1 half outside of everything. I'll just go ahead and work this out and then multiply my end result with 1 half. So what I end up getting there should be ln of 10 minus ln of 5. Okay, and the trick here is that the ln of natural log of 10 is the natural log of 5 times 2, which, using your properties, it's ln of 5 plus ln of 2. So ln of 10 is ln of 5 times 2, which is ln of 5 plus 2. Okay, so I can change ln of 10 to ln of 5 plus 2. Or I should say ln of 5 plus ln of 2. So then these cancel out. You're left with 1/2 times the natural log of 2. So your answer here is B for another point. Alright, problem number 3, the average value. So when they're asking for the average value, you should automatically think of that setup for the average value, which is 1 over b minus a times the integral of from a to b of f of x dx. And so my intervals from 0 to 2, so a is 0, b is 2. So this is what I'm looking at. 1/2 times the integral from 0 to 2, x squared radical x cubed plus 1 dx. Alright, so we're going to have to integrate, and we're going to have to do u substitution where u is x cubed plus 1. So that makes dx equal to 1 over 3x squared dx. Ooh, that's not dx. That should be du. So if we take out this 1/3 out, and we already have a 1/2 outside of the integral. So 1/3 times 1/2 is 1/6. Or 1 over 6 times the integral of radical u du. Remember, I'm not putting my limits, 0, 2, those are x values. Right now I'm integrating with respect to u. So integrate this using the power rule for integration. So we get 1 over 6 times 2 over 3 times u to the 3 over 2. And I'm ready to plug x cubed plus 1 back in for u. And now it's fair to write x equals 0 and x equals 2. Okay, so I'm ready to plug them in. Capital F of b minus capital F of a. Okay, and what I did is I did 2 cubed, which is 8. 8 plus 1 is 9. Now, 9 to the 3/2 is the square root of 9 cubed. Now, you can also write this 9 cubed, or the square root of 9 cubed. So you could, the only thing is that this is going to get messy if you try to do 9 cubed and then square root whatever 9 cubed is without a calculator. So I wouldn't recommend that. You can just as well write the square root of 9 and then cubed. And then that'll just be 3, and 3 cubed is 27. So it's a lot easier to do this without a calculator. So these are both equivalent. However, this is messy and long without a calculator. This one is easier. And then I did the same thing after I plugged in x equals 0. So 0 cubed plus 1, and I have the square root of 1 cubed. So doing some arithmetic, you have 1 over 6 times 54 over 3 minus 2 over 3. So it's 1 over 6 times 52 over 3. This is just 52 over 18, which gives off 26 over 9. The answer here is A for another point. Alright, let's go to problem number 4. Now, problem number 4 might have been easier if you just graphed or hopefully visualized the graph. But if you just did a quick sketch of the graph, that might have been a lot easier than trying to calculate this using the piecewise function for the absolute value of x minus 3. So here I have the graph for the absolute value of x minus 3, and we're integrating from 1 to 4. So let's just focus on the area underneath the curve from 1 to 4. So we have two triangles, base times height divided by 2 for this triangle, plus base times height divided by 2 for this triangle. So we have 2 times 2 divided by 2. 4 divided by 2 is just 2. And base times height divided by 2, that's 1 times 1 for the second triangle. So we have an area of 1/2. 2 plus 1/2 is 5 over 2. So your answer should be C for another point. problem number 5. Now, with problem number 5, I did do a slight of a mistake. When calculating h of 2, you can't really calculate h of 2, but you can definitely approximate it and get really close to it. The reason why you can't get the actual area is because this is a curve. So it's not a straight line. If this were a nice straight line, then we can use the area of a trapezoid, but it's actually curving, so we're going to approximate it. So using our h of x equals the integral from 1 to x of f of t dt, we have this setup, and when we integrate, we're just looking at the area, so we take this square, which is 1, plus, and if we look at this as a triangle, that's 1 plus 1/2, which in this case is 3 over 2. Or I should say approximately 3 over 2. Next, most likely on the test, on the AP test, you'll be able to actually get the actual area, not an approximation. For calculating h prime of 4, you're going to use h prime of x equals f of x. So h prime of 4 should equal f of 2. And f of 2 is this point right here, so that should be 2. This is 1 point for part A. Alright, part B. Now, explanation is key for part B and part C. So in part B, we're looking for the maximum for h. And if we're looking for the maximum, we are looking for the derivative. We're using the derivative of h, which is the equivalence of f. Because remember, h prime of x equals f of x. Now, if it's a maximum, we want to see where the slope for h changes from positive to negative, or that's the equivalence of asking where does f change from positive to negative. And you can see that it changes. This is all positive, and then at x equals 5, that's where it changes to the negative. So at x equals 5. Okay, and there's a sample response. This is 3 points. Now for part C, you want to see where h is concave up. So if we're looking for concavity, we're looking for the second derivative, or we're using the second derivative. So h double prime of x is equivalent to f prime of x. Now what we're looking is, we want to see where is h double prime positive, because it's concave up. Well, h double prime being positive is the equivalence of f prime being positive. So here we can look at the graph of f and see where do we have a positive slope. We have a positive slope from 1 to 3, and then we have a positive slope from 6 to 7. From 3 to 6, it's negative. The slope is negative. Okay, and here is your sample response for part C for another 3 points. Alright, slope fields. Alright, so for problem number 6, you do not have to solve the differential equation. You just have to sketch the slope field. So you don't want to waste time solving when they don't ask you to solve, because that'll be wasting some time. And I'm running out of time, so let me just show you the key. Since x to the 4th is always positive, the y value is really what's going to determine your slope here. So this is what you have. Here are some givens, the slopes of 0. Okay, here we have positive 1, negative 1, and negative 2. Alright, problem number 7, I was looking that you correctly separate the variables and integrate correctly. If you didn't get this part, you probably didn't get any points. Now, there are many ways you could have solved for C, or many different values what you got for C. I got C equals 48. And down here is how I got the negative outside of the radical.